Welcome to the OscopeWizard. I'm Gabe, the OscopeWizard. Thank you for joining me on this Tuesday. And I think I got all the technical bugs worked out over the weekend, I believe. I've gone back to my trusty borrowed camera and given up on ever owning a camera that will actually work for me, for the time being anyway. Hopefully you guys had a wonderful weekend. It sounds like for some folks, it's a little chilly today. It's June, which is generally a summer month, and yet one of my viewers is living in a place that is still 40 degrees, and it is in the contiguous 48 states, so it's not some far-flung region up in northern Canada. But down here in the southeast where I live, it is quite muggy. It is probably 80 degrees outside and 90% humidity, 90. That is very humid. That is hard to breathe humid. It feels like you are running through water. All right, and I got some feedback. The video quality is super clear and the voice matches the picture. Yes, finally. We worked so hard. By we, I mean me. It's mostly just me down here in the techno lair. And I really appreciate you guys joining me. As usual, I don't know all the nerds in the world, so please share this with the nerd in your life and let's expand the viewership. Today, I do have my timer, so we are back on track. I also got a couple of cool things in the mail, so we'll start there. I actually, before we get too far, I wrote down on paper. You can, oh, there we go, we can see it. I wrote down on paper some show notes to keep me on track because I sent out a few invites to the show and I said that I would do a few things specifically. In order to make sure that I keep myself on track, I made kind of an outline, as it were, an agenda. But let's start in the mail. So in the mail this weekend, I have been using this multimeter since college. It is getting a little old. It does have a dial, so anything with a dial looks ancient. I mean, it could come out today, and if it has a dial on it, it looks like I'm some kind of steampunk freak that wants to wear goggles and drive a locomotive around on the road. But having a dial means that it's a little bit imprecise and it's a little bit hard to read. There's a whole bunch of gauges with a bunch of little numbers on them. So for $40 on Amazon, I bought myself a digital multimeter. I have not opened the box at all. I'm going to save that for Thursday. Cliffhanger. There's going to be a box opening on Thursday. I'm going to see what is in the box and how this looks, how it stacks up. It looks like, as far as this multimeter from just the box versus this multimeter, it should outperform it in every way possible, including ease of use. We'll find out Thursday. Tune back in. Another thing, which is going to be the point of today's show, another thing that I got over the weekend, which I was very excited about, was I just looked over at the chat, and before I do the big review, there's something wrong with the video. Some of your hair is a bit grayer than the rest. Oh no! I didn't put in my not gray filter. I actually considered last week shooting all of my future videos in black and white to not deal with color correction and differences between cameras. And I feel like there is like a strong argument to be made for shooting in black and white. And one of those arguments is just my hair will become, you know, this sheet of gray, and no one will ever know how gray it actually is. Back to, that was hilarious, by the way. That was hilarious. I think I even have, I don't have my laugh track set up right now, so I can't even do the laugh. Ha 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 ha. In the mail, let me hit go. So, because we're getting into the meat of the matter here. So start the timer. In the mail, I got a resistor. Have you guys ever seen, let's see, put it back here, a resistor like this? My challenge that I have faced over the course of last week's episode was that making Bode plots is cool, and I'm using my oscilloscope to make Bode plots of my audio amplifier. And if you guys remember, Bode plots are basically a rough estimation of the frequency response of my amplifier. Making those Bode plots with these speakers, though, so I was using these speakers here that you can see, which are the speakers that came from my old component unit, is loud. It is very loud. I mean, they're like, you have to hear the noise with your ear holes, and it was hurting my poor ear holes. So in an effort to protect my ears, I bought these power resistors. Now I am familiar with resistors like this, so this is a pretty in fact, this is one of the resistors I used in one of my previous episodes. I think it's 100. It might be. This one might be a 10 ohm one. Actually, that one's 100 ohms, isn't it? So it's brown, black, brown. I think that's 100 ohms. Or resistors like this. So I have, in my previous work that I have done, I've used a lot of resistors like this. So this is a typical circuit board, and on the circuit board are a bunch of little components, and some of the components are these tiny little resistors. You can barely even see them because I think my webcam is going to really struggle to focus in. There it goes. That with the 0 on it. I should probably not be a surgeon. Look at that's as still as I can hold it, guys. That component with the 0 on it was a 0 ohm resistor. Those resistors are tiny. So this is the resistor. This is my 100 ohm resistor. This is my 8 ohm resistor. This thing is made out of concrete. Concrete? Has anybody seen a concrete resistor before? Anybody in the chat around? It's my mom. If she's on, has she seen an 8 ohm resistor that's made out of concrete? I had not seen a concrete resistor, but I don't think I can burn it out. It's supposed to be a 50 watt. You can even see right here, 50 watt. Let me turn my camera so it's not. There we go. 50 watt, 8 ohm. I don't know what RJ stands for. Probably really full of juice, maybe. I don't know. RJ. It's probably some kind of a quality rating. But I thought the first things that I could do here is we can use, I have a multimeter right here. I can start, super simple, let's measure this resistor. See if I can figure out if it really is 8 ohms. So I'm going to plug in my leads into my multimeter here. I'm going to clip onto my resistor. So I have my leads right here. Clip onto my resistor. Resistors don't have directionality, so it doesn't really matter. But I have a little problem with color matching, so I'm going to plug black to black and red to red. There we go. We can see 9.6 ohms. So this 8 ohm resistor is 9.6 ohms. So it's a little bit off. I have 2 of them because I had 2 outputs on my amplifier. So if I hook into this guy right here, 9.5 ohms. And in fact, I have this connected to my probe, but my probe has a high enough resistance that you can see the resistor drives the resistance of this whole circuit, just as it should be, because you want most of the current flowing through the resistor and not through your probe. So 9.6 ohms, 9.5 ohms, not 8 ohms, but also not a million ohms, and it also doesn't make noise. So now, I thought I could use these power resistors to measure the frequency response of my amplifier. I want to do that. I also want to tune my amplifier to make sure that I'm getting the proper power output, because if you remember back, we looked at the data sheet, and I think we might get back into that data sheet a little bit, because there's no reason not to. This amplifier, while it was sold to me on eBay as a 150 watt by 2 amplifier, is not true. It is actually a 50 watt by 2 amplifier, as long as you use 24 volts on the power supply. That's what the datasheet said. So let's get into it. Let's make some tests. First things first, I need to energize my circuit. So here's my power supply up here, up top a little bit. You'll remember I got a 24 volt power supply to replace my 12 volt power supply. This is another one that I bought off of eBay. I'm going to plug that into my amplifier. Over here I have my breadboard that is wired into the signal generator coming from the back of my oscilloscope. And there I have my trusty RTO 2044 that is going to make the measurements on both the input signal, so the input signal, and we're going to compare that to the output signal. And that's how we're going to make this Bode plot measurement, and how we're going to do all sorts of different measurements on power output, frequency output. Yeah. Oh, power it up, Gabe. Power it up. My mom picks on me because one time when I was having trouble with the computer when I was younger, couldn't figure out the problem. She comes in, she says, well, did you plug it in? And she has never let me forget that day that she remembered to plug something in, and I did not remember to plug it in. So I have plugged it in. Let's see. Let's go over to the DC voltage, 24 volts, so measuring 24 volts. So I have this thing tuned to 24 volts. So my amplifier is energized at 24 volts. Can we see everything? There we go. You can see the whole circuit now. And there was a question, was the resistor tolerance specified? And the answer is, oh, no, it was not specified. It was just 50 ohm resistor, or 50 watt resistor, 8 ohms. I think that is exactly how it was specified. Let me just make sure that I didn't miss something. Here we go. I think I can go over and show you the, let's see if it'll do it. Oop, got all kinds of stuff happening, popping around. There we go. Here's the listing that I bought. So this was the, it says 8 ohm, 8R, 50 watt resistor. 8R may be a nod to the tolerance. So here we go. 8 ohms plus or minus 5%. What is 5% of 8 ohms? 8, let's see, 8 times 0.05 equals, so this resistor should either be 8.4 ohms or 7.6 ohms. So I guess this is actually way out of the specified tolerance on eBay. But if there's anything I've learned from buying components on eBay, is that the specs that they give here in the descriptions, they're often wildly inaccurate and based on nothing except a feeling. So the 20% is much more usual for a resistor. So you'd have a 20% tolerance. So that means if it was 8 ohms, and you went back in here and you said 8 ohms times 0.2, okay, so then it could be 9.6 ohms, which would mean that I have 20% tolerance resistors and not 5% tolerance resistors. All right, so whatever. You live and you learn about tolerances and data sheets, and we're getting deep into data sheets and deep into trying to make all of this work. My head looks really small from Ireland. It did get shrunk. It is shrunken in the corner as we look at the rest of my desktop. I'm just trying to get out of the way so you guys can see the cool stuff. Let's go over to the scope. Let's show the scope. There we go. And what are we doing today? We are checking out some mint resistors to see what they're for, why I would use them, how awesome they could be. Mostly they're for preventing me from frying all my little axial resistors that could in no way handle 50 watts of power. this amplifier that I'm using allegedly will output 50 watts of power. I have yet to be able to do that. I've tried to do it. But we're going to start simple. We're going to start simple. All right, we have plenty of time. We're going to go back into my BodyPlot app, and I need to pop over to the BodyPlot app. Let's minimize that application. Here's my BodyPlot app. Need to set it up. So my start frequency is 20 hertz, and my stop frequency is 20,000 hertz, because those are the frequencies that my ear holes can hear and respond to. My ear holes run out of gas at around 15,000 hertz, though. We'll do a 20% step size, so still pretty large steps, but we're gonna shrink that down a little bit. And I was doing 100 millivolts in, and then the amplifier was amplifying that signal to send the larger signal out, which is what the amplifier does. So, got everything plugged in, got the circuit energized. If I hit run, let's go back. I'm not using 50 ohm internal, I'm using 1 meg internal. And then over here on my oscilloscope, before I get too deep into this, I added a preset button actually up here. So, step 1, when you're using a piece of test equipment that you haven't used in a while, preset it. Because that's what pros do. I have preset it. Now, let's go back to my BodyPlot application and hit Run Test. Got it all set up. Hit Go. Let's see what happens. I forgot a step. I forgot to change my scale for my gain. So right now what I see is my phase. If I remember properly, my gain, though, is 35 dB. Is that right? Yeah, so let's make this 40 dB here. Yeah, there you go. So it gets up to 35 dB. Around 100 hertz, it gets to full amplification. So what I think I want to do is go from 40 to 30, and let's do it in 1 dB steps so that I can see a little bit better what's happening right here around my band pass, which is from about, let's see, 10, 20, 30, 40, 50, 60, 70. So from about 70 hertz to 20 kilohertz is my pass band. So that is the frequency band that is actually being passed by this amplifier. When I run this test, let's see. Yes, there was just a question. Can we see the scope screen when we're running the test? Yeah, that was, man, it's like it's almost like I shared the script before I did the video here. Let's go back over here. Okay, so we can see channel 1 is my pink channel. Channel 2, my green channel, that's my output. So my pink channel is my input. My green channel is my output. So that was pretty fast. But you'll notice at the very beginning, the green channel is off the screen, so it's having a little bit of trouble with scaling at the very beginning. So I think that might be actually throwing my BodyPlot off a little bit. So what I was going to do is 2 things. You'll notice that right now I'm at about 2 volts per division, and I have 1, 2, 3, 4, 5, 6. Let's say 6.5 divisions at 2 volts a division. So that means if I make a measurement here, let's just measure this peak to peak of channel 2. I'm curious. 13.59 volts. 13 volts. I'm pushing in 24 volts. If I go back to my desktop really quickly and look at my data sheet, one of the things that I noticed is that the power output was very dependent on V peak, which was one of the reasons why I switched from a 12 volt power supply up to a 24 volt power supply. Because with a 12-volt power supply, I could only ever hope to get 25 watts out of this amplifier. And with a 24-volt power supply, I could potentially get the full 50 watts. Now, my output voltage in RMS needs to be 17.9 volts to get peak power from this amplifier, according to this little power limit example. If I go back, so that's not peak power, but that is very high. So if I go back, peak to peak power, and I got a blank screen, so I want to show the scope. Peak to peak power is not the same as RMS. Luckily for me, I have an RMS measurement. So RMS of channel 2. RMS of channel 2 is 4.6 volts. 4.6 volts. Not terribly impressive. So what I want to do is two things. I want to reduce the step size of my Bode plot, because that is going to give me a more detailed picture of this frequency response and the phase response. And I also want to boost up the generator voltage to try to see, that would be like turning the volume up on your source, your iPhone. So if I was using this amplifier with my iPhone, I could turn up the volume on my iPhone, you know, just using my volume rocker here. That would increase the voltage going into my input on my amplifier, which would in turn increase the voltage coming out of my amplifier, which would make it louder for my ear holes. Whole point is to get some noise into ear holes, that sweet, sweet bass, that sweet, sweet sub bass. Nobody wants the bass anymore. They want the sub bass. They want that rock in their gut. Okay, let's reduce the step size. So I'm going to reduce this step size to just 5%. So it's a smaller step. I'm going to, so before I go crazy on the generator, I wanted to show you one other thing here. In the data sheet, it actually specifies the maximum amount of voltage that can be on the input. So these input left and input right here. So the maximum voltage that can go in is 6.3 volts. So if I send in 1 volt, that is plenty of volts. And also I'm well within, actually it might not be plenty of volts to get my maximum output. It is well within the safe range. Also, my power supply can be boosted up to 30 volts safely. This says absolute maximum ratings. I think the recommended operating range is 26 volts. Does it have a recommended operating range for the inputs and outputs for the audio? It does not. Okay, so we'll stick with the absolute range for my audio ins and outs, which is minus 0.3 volts to 6.3 volts. I'm going to go back to my scope, turn off my desktop, back to my scope. Let's crank up my voltage peak to peak input to, let's say, 1 volt. And so now I have a smaller step size, larger input voltage. My volume should get louder. If I still have my speakers hooked up, this would be so loud. It would be very loud for my ears, which is one of the reasons why I love having these power resistors. These guys right here are awesome for this test. That is exactly what these guys are made for. And in fact, I can feel them getting a little warm, so I can feel them working a little bit. You guys keep putting in that work now. So, back to the scope, back to running the Bode plot. Hit go. Let's go back and look at what the signal looks like. So I'm curious what the output signal is going to look like. So what is channel 2 going to eventually look like? This is what I noticed. This is what I noticed when I started cranking up the input voltage is, look at my output. Does this green channel look like the pink channel anymore? Is there a difference? Can anybody see a difference? Does anything look weird? I want a sine wave to come out because that's what's going to sound beautiful in my ear holes. But I'm sending a sine wave in, so this smooth, beautiful sine wave is going in, and, ooh, oh my gosh, okay, oh my gosh, okay. Woo. 5 minutes left. 5 minutes left, which is good because I'm actually getting through what I said I was going to get through. It's a miracle. I'm actually doing it, guys. I'm doing it. I'm staying on task a little bit. Back to the scope. Input, pink signal. Output, green signal. Does the pink signal match the green signal? Anybody? Anybody? While I'm waiting for answers, let's go back and measure the RMS on my green signal. Okay, so my green signal RMS up to 15 volts. That is getting close to maximum voltage, which is awesome. I think, in fact, if I go back to my data sheet, if you remember properly, 8 ohms. The highest voltage I could ever hope for was 30 watts, or the highest power I could ever hope for was 30 watts. Yes, somebody did respond in the chat, and they said, this looks like what heavy metal would look like. And yes, when you send a guitar signal through a distortion amplifier, the whole point is to chop off the tops and overdrive it so it looks like a signal that kind of resembles this green signal. That's overdriven. What we are looking for, though, is perfect reproduction of the input to the output. So I am overdriving the output right now, and I am not exactly certain why. If I go back to my Bodhi plot to see what that turned out to be, you can see it's off this. It's gone off the screen somewhere. If I let's make this 10. Okay, you can see. Okay. Look, you can see my gain was at 35, so it was at 35, but my gain has been pegged out at 28. So if I go to 30 here, change my scale to 1 dB per division. Oh my goodness, you can see 27, and then it falls, and so it's doing weird stuff because I'm overdriving the output. Clearly there is a tightrope to be walked along to figure out what is going on. Let me switch over to the setup real quick too. You'll notice that this power supply was at 17 or 24 volts. Now it's down to 17 volts. My little power resistors are getting quite warm. So I need to go into my waveform generator. Let's turn that thing off so that I don't burn up my resistors, which they're not going to burn up because it's 50 watts, and I could only ever output 30 watts into 8 ohms. But look, 24 volts when the generator is off. When the generator is on, 17.7 volts. There's more to be learned here, folks. More to be learned. So join me on Thursday, where we're going to learn more. We're going to go deeper into trying to tune the output of the amplifier so I'm not overdriving my speakers, because eventually I'm going to replace those 8 ohm speaker or 8 ohm resistors, those 8 ohm lumps of concrete, with speakers to put music into my ear holes. And when that happens, I don't want it to be overdriven, because if overdriven speakers sound terrible. They sound absolutely terrible. They buzz and they hum and they add all this extra sound, which is never good. Also, we're going to unbox the digital multimeter and use it because I'm curious what the current draw is from my power supply. And I can't measure current and voltage with the same multimeter right now because of the way it's all cabled up. So that's, I don't think I can, I may be able to make that happen. I haven't exactly figured out how to make that happen. But I'm going to use 2 multimeters, mostly also because I want to see how my new multimeter will work going forward. Is it okay for $40? Is it an okay multimeter? Again, I don't know all the nerds in the world, and I would love to meet them. So please share this with a nerd in your life and in the world, probably. And I'll see you guys again on the next OscopeWizard, 11 a.m. Eastern Standard Time, Tuesdays, Thursdays. Next one's on Thursday, also known as Baby Friday. Stop saying Thursday. Let's call it Baby Friday. I'm going to hang out in the chat. You guys, take it easy, and I'll see you next time.